So, of course, this week's topics, chapters 1 and 2 of CCNA 3 are OSPF. And so I'm going to demo that. So the first 6 items on this list are actually OSPF. And then also I'm demoing a bit of an idea of what the prac test will be in a few weeks' time. So I've thrown in some spanning tree settings and some other switch security settings, and then also some wireless as well. So we've got, when it comes to OSPF, we've got this network here, and so I've designed it with this Ethernet switch in the middle just to make it a large broadcast multi-access network that, of course, OSPF will need to elect a DR and BDR to work as per design. And so we're going to just play around and have a look at the settings for that. So we've got this central network, 10.0.0 is where the routers all hooked together. And then off of router 1, well, we've got 2 networks, one for the wireless, which we're going to play with a bit later. So 10.99. And then there's 10.1 also off of R1. There's 10.2 off of R2. There's 10.3 off of R3. And there's 10.4 off of R4. There's IPv6 addresses there, but I'm actually not using them today. So the addressing is done on all the devices, except maybe the wireless access point and wireless client. So all the addressing has been done. And so there's, as you can see there, there's sub interfaces there for VLAN 1 for the server that's connected, and then there's VLAN 99 for the wireless network. And so this is a trunk link between the switch and the router. So all the others are addressed, but you know, there's just one LAN and then the common LAN between them. And so the addressing's been done, but of course there's no routing protocol, there's no static routes, there's nothing like that. So step 1 is to just do a basic setup of OSPF, and then step 2 is also to set the router IDs. And so of course with OSPF, it needs a router ID to operate. And so there's 3 places it can get a router ID from. The router ID command. So if you do that, of course, that's pretty strong argument that that's what you want the router ID to be. And so that's the sort of the top preference when it comes to router ID. If there's no router ID command, it will look for a loopback interface, and it will use that address. Again, because it's a loopback interface, it's not dependent on a physical interface, and so it's more likely to be up. And then, of course, the least preferred option is to take the address from a physical interface. And so the downside of that is that, of course, if the physical interface dies, the OSPF is going to be a little unreliable. Also, if you've got no physical interfaces up and you try and activate, and no ID or loopback interfaces as well, if you try and start OSPF, it actually will not start because it can't figure out an ID. So it will actually refuse. All right, so that's the router ID. That's part 2. Part 3 is create a loopback interface on R1 and create a default route to it. So that's going to be our default route to the rest of the world. And then you need to advertise that using OSPF. So you don't put a static route, a default route on all the routers. You just put it on R1 that's directly connected to that default route, and then you use OSPF to advertise it. Now, basically, we are going to manipulate the DR-BDR elections. So because it's on a multi-access network, it will elect a DR and a BDR. Often it's the order that they boot or that you configure them. But of course, eventually it will go to how you've manipulated that. And so basically it will use the interface priority as the first thing to check whether it's going to be a DR or BDR. But of course, if you haven't set that, all the routers will have a priority of 1. So that's going to be a draw. And then, of course, it will be the router ID. And so in this case, long term, R4 would end up being the DR, and R3 would end up being the BDR. But we're actually going to make it so R2 is going to be the DR and R3 is going to be the BDR. So we're going to manipulate that somewhat. And the last thing we're going to do with OSPF is to set the hello time to 20 seconds and set the dead time to 60 seconds. So normally it's 10 seconds and 30, and so we're doubling those times. And so now, when you do that, you need to do it on all the routers that are talking to one another, because that is actually one of the parameters that they compare. If with OSPF, if one router says it's 10 seconds for the hello time and the other one says it's 20, they will not form adjacency. And so if I configured R1 first and just left it, it would actually lose adjacency with all the other routers. And so you've got to do all of them for it to work. Now we're going to getting into the spanning tree, and so we're going to make all the host ports port fast, so they cycle straight to forwarding when the link comes up. Of course, that's basically turning off spanning tree on that port. And we're also going to turn on BPDU guard as default for any port fast ports. And so, of course, a port fast port means that, hey, I've got a host connected to this port, and so you should not be getting any BPDUs from that port. And so having that on is a good way of basically blocking a possible attack on your network. We're also going to turn on port security on those ports, and also with an extra setting of it learning the MAC addresses and remembering those MAC addresses dynamically. And so we'll do that command, and then we're going to configure the wireless. And so we'll address the wireless access point, and then we'll set the wireless security settings as well. So that's the basic behind it all. And so, of course, I have a packet tracer. And so, that's down the bottom. We have the basic OSPF, which is the first two parts. And so, of course, to turn on OSPF, it's router OSPF, then you need to supply a process ID. So, imaginative as I am, I chose the number 1. And then, as in point 2, it says set the router ID. So I thought I'd do this all in one hit and use the router ID command. And so, of course, this is router 1. I'm doing all the 1s. On router 2, I'm doing all the 2s, 3 all the 3s, and 4 will be all the 4s as per the requirements. Now, the next command of importance is the network command. And this actually tells OSPF what networks are participating in OSPF. Now, if we look at router 1, it's got 10.000, it's got 10.10, and it's got 10.99.0 networks connected to it. And so they're all part of the 10 network. So I've been lazy or efficient, either way, and I've done it all in one command. And so, of course, it's network. You then supply the network number, and then OSPF actually requires a wildcard mask. Now, a wildcard mask we will actually look at again next week for access control lists, but basically with a wildcard mask, again, that's a 32-bit number. Wherever there's a 0 in that number, the bits must match. Wherever there's a 1 in that number, we don't care if they match. And so, as you can see, the only bits that I care about are the first 8. And so, basically, any number that starts with a 10, I want that to be part of my OSPF. And so, of course, on router 1, all of the addresses, except for when I create the loopback address, all of those addresses are all part of the 10 network. So, one-stop shop for that with one command. Cisco often teaches to do it on a per interface basis, but with a simple network like this, this will work beautifully. Now, passive interface, have we heard of that? No. All right, so passive interface is basically, oops, I'll just take it away. Passive interface is basically turning off sending and receiving OSPF messages on that interface. Now on VLAN 1, there are no other routers because there's just this server, possibly other hosts. On VLAN 99, there's just the wireless access point and wireless hosts. And so there are no other real routers. This router is just going to have a default route, and that's all it needs. And so that's basically it. And so basically they will still be advertised by router 1 to the rest of the network, but there will be no hello packets or any other updates sent out to those. And so, yeah, they're the sub interfaces, of course, for the VLANs. But again, if we look at router 2, it's a physical interface only, and that's G01 there, this network here. There's no routers. There's no point to having OSPF packets going over that network. So it's efficient for your bandwidth. It's also secure. So if there's a compromised host and they can see your OSPF advertisements, they're going to learn some information they wouldn't have already learned. So again, that's also better for security. All right, so and log adjacency changes just means you get a message on the console if you get or lose full adjacency with another router, basically. All right, so we might as well start configuring OSPF. Copy router 1 and paste. No errors. Of course, it's the only router with OSPF at the moment, so not much is going to happen. Go to R2, do its configuration as well. Now, something should happen now because there's 2 routers with OSPF. And so we should actually get an adjacency change message on the screen eventually. Always love waiting. Come on. That's taking a lot longer than I was expecting. Probably would have done it. Might be. Oh, there we go. OSPF neighbours. So I'm doing show IP OSPF neighbours. And you'll notice that router 2 seems to be DR this time. Last demo, router 1 was. And so we've got full adjacency with between router 1 and router 2 now. And so if we do show IP route, of course, this is on router 1, so it's directly connected to network 0 and network 1, which of course is what the server's hanging off of. There's VLAN 99 again that we're directly connected to, and then we've learnt this network 2 from router 2. And so you'll notice that the priority here is 1, and so that's the default. And so, yeah, away we roll. So let's have a look at router 3 now. Get that going. We should get an adjacency message then. Wow. There we go. Two adjacency messages. And so, of course, with both router 1 and router 2, of course, this is router 3. And so we'll do router 4 as well while we're here. And basically, the only difference between them is the router ID command. So let's fast forward again. And so we have 2 adjacencies there. Now, if we do show IP OSPF neighbor, router 2 is the DR, router 1 is the BDR because they were the first 2 up. Now, router 3 is called a DR other. And so that's basically what routers are when they're not a DR or BDR, it's a DR other. And you'll notice that router 4 would also be a DR other, it's just not because it's itself, it's not its neighbour, so it's not displayed. And so between router 4 and router 3, they actually don't have full adjacency because they don't need it. And so basically, if router 4 were to notice a change in the network, it would actually send it to the DR and BDR and no one else. So it doesn't need to have full adjacency to the others, because the whole point of having DRs and BDRs is to cut back on the traffic. And so, yeah, my router sees the hello packets from the other one, and that's it. That's what it means by two-way. It's sent hello packets and it's received hello packets. That's the only real communication I've had, because they don't really need to maintain adjacency. All right, so we can do show IP route now, and it should show us a lot more. And so, of course, all the routers are connected to the 10.0 network. It's learnt 10.1, 2 and 3 from the other routers using OSPF. It's directly connected to 10.4 as well, and of course it's learnt 99 from OSPF as well. So that looks like a pretty decent routing table. So let's try doing some ping just to make sure it works. Ping 10.1.0.10 is the server. Might have the odd ART request. Again, holding us up a bit, but it should work eventually. It's all good. Host off of router 2 is that address. It's probably pinging itself, but well. And so we've got, of course, we've got 4 as well. There you go. Took an extra packet to get through, but it did get through. I was a bit worried I hadn't put the IP address in, but anyway. So that's OSPF working nicely now, and so that's all very nice. Now the next step is for us to create a loopback interface. So I've done that here, and so we've got interface loopback 0. I've set an IP address of 411s. Because, again, imagination is a problem for me. And then I've created a default route, so IP route, quad 0 is a destination, quad 0 is a mask, and the exit interface of loopback 0, which of course is that. So that's a default route. So I'm going to put this in router 1 because that's where I've been asked to put the loopback. And so router 1, at this stage, router 1 will have a default route. Then we go into the router OSPF command and tell it to originate default information. So in other words, if you've got a default route, advertise it basically. And so that's basically all that's required. So if we look at this router again, did we look at the, no, we haven't looked at the. Just because I didn't have anywhere else to put it. I hadn't created another link for it to be an interface default route. And so you'll notice that we've got a gateway of last resort is not set on R3. So it doesn't have a default route yet. And so we'll try and get that learnt. So we'll, again, copy and paste this into R1. Could be any router, I suppose, but paste, show IP route. So now we've got we've got a gateway of last resort, and we've got this S star, which of course is static candidate default route, and of course the destination is quad 0/0 out to loopback 0. And so that's now got a default route. And so let's have a look at another router. We'll see immediately what changes there are. So now, previously, of course, we didn't have a gateway of last resort. Now we do. And of course, the gateway of last resort is 10.0.0.1, which is router 1. Now, of course, it's not a static route on this router. It's been learnt from OSPF, but it's got a star there, so it's a candidate to be a default route. It's also an E2, which means it's an external route, so it's come from an external source. So, of course, it was a static route, wasn't it? And so that's the external source, and so it tells you all about it. And so, as you can see, it's got that route. It's got this, the admin distance for OSPF is 110, and the metric for this is 1, which isn't much because it's a gigabit link between them. So that is a default route, and it's been advertised. So we're now down to 5. So we want to make R2DR, which it already is, but anyway, designated router. So basically it's sort of like the admin staff sorting all the information out, basically, instead of everyone trying to do everything themselves. Just send it this one central point, and then they'll distribute it to who needs it. And so a backup designated router, shouldn't click on that, should I? Of course, will take over if the DR fails. And so how do we do that? Now, basically, I've got a variety of 3 commands that we can use. Now, what I'll do is I'll make IP OSPF priority 100. Of course, the default setting is 1. That's all we've seen up until now. If I make it 100, of course, that's a lot higher than 1. So cool. That will end up being the DR if we reset things. I'll set R3, which is supposed to be BDR, to have a priority of 50. Now, the priority of 0, I won't use it, but that priority, of course, will mean that if I were to use it, it would mean that particular router will not become a DR or BDR at all. So that, of course, it's lower than 1, and it's the lowest possible setting, of course. So I'll paste this one into R2. So, of course, it's on a per interface basis, and so G00 is the interface that's facing this central LAN from all the routers. So, yeah, just a bit convenient. Now, I'll edit it for R3. Of course, the exclamation mark just comments it out. So the only one that applies at the moment is the 50. Now, if we do show IP OSPF neighbor, you'll notice that you can see the new priority. Can't see the 50 because it's on the router we're sitting at. And it was already DR anyway. Now, router 1 is down there as BDR because that's just the way it was. It doesn't change it doesn't do a new election unless it needs to. And so, of course, the DR and BDR are both working, so it will stay that way. And so we need to do something to make it happen. So what you can do is maybe shut down an interface and then bring it up, or you can do what I'm assuming the curriculum says, is to clear IP OSPF process. And that basically blanks out OSPF and starts it again. So what I'll do is I'll do it on R3. See what happens there. Now we've lost adjacency and we're gaining it again. Let's do that show IP OSPF neighbor again. So 2 is the DR, and I can see 2 DR others. And so of course, that's routers 1 and 4. So this router must be BDR. So if we look at it from, I suppose router 4 will do. Show IP OSPF neighbor. You can do show IP OSPF, I think it will just talk about itself. And so as you can see, router 2 is the DR, router 3 is the BDR. And so, of course, now router 4 has a two-way only adjacency with router 1. So that's again back to what we needed to do. So there's one more thing we're doing with OSPF, and that's the timers. Scroll the wrong way. And so IP OSPF hello interval 20 and IP OSPF dead interval 60. And again, you do on a per interface basis. Now, as I said, it will break adjacency. If I do it quick enough, it won't lose it because, you know, there's the dead timer of 40 seconds, I think. And so it may not lose adjacency if I do it quick enough. And so I've done the hello timers on R1 and on R2. And on R3. And on R4. So let's do show. No. Now. So now you can see that one seemed to wind down for whatever reason. They hadn't exchanged matching hellos yet, but it did come back pretty much straight away. And so now you can see that the dead time is more than 40 seconds. And of course, these are nearly a minute. So that seems to have set. And now, of course, we lost adjacency because they didn't match, but we've gained it again straight away, I think. It hasn't shown it because it never made full adjacency because it's router 1. Okay, so I think that's pretty much all we're doing with OSPF. Down to 6, yeah. All right, so now we're going to do some spanning tree settings. Now, it said to make the port fast, and so that's the command to do that. There's only one interface on each switch with a host, and to make a port fast, it actually needs to be in access mode. And then you can do spanning tree port fast. And of course, we wanted to have BPDU guard on by default if a host was in port fast mode. I mean, a port was in port fast mode, and so that will be turned on as well. So I won't do it on switch 1 just because, I don't know, I've got VLANs on it. I'm not going to bother. It shouldn't really matter, but I think 3 switches is enough. Did I not copy all of it? Ah, clever boy. No, it doesn't, does it? Of course, I'm recording this joy of joys. There we go. So we've got it in access mode, we've got it in port fast, and then we've done the default settings. So we can do a show run, have a look at the port. Well, there's the BPDU guard there as the default setting, and then port 24, got it in access mode and it's in port fast mode. Now you can do show spanning tree summary. and it tells you that BPDU guard default is enabled. So all good. Now, I suppose we need to do that on, oh, what am I doing there? That wasn't the way I meant to scroll. We'll add it to this switch as well. And this one. All right, so that's the spanning tree done. Now we've got to do the port security. Now, again, it's only going to be interface 0/24. So switch port security, of course, turns it on. Can't forget that. If you don't do that command, plain command, it is not on. And then remember, we wanted to learn MAC addresses dynamically, but remember them. And so that's the.
The other day with that, because I turned on port security.
Yep.
And one of the tracks that asked you to make it static, I couldn't learn it dynamically because most of the tracks to it.
Yep.
It wouldn't accept the static one because it was saying the duplicate.
Oh, okay.
And it took a while to realise you actually take the dynamic one and then the static one. Yeah.
So, of course, sticky will mean that it will actually learn the MAC address and put it in the config, the running config at least. If you do a copy run start after it's learnt it, it will actually put it in the startup config as well. Oh, I didn't actually do a copy paste with that. So this is all we need for that. Again, I'm only doing it on one port. Again, I'll just do these 3 switches. No errors. No errors. All right, let's do some pinging again. Well, that's the 3 hosts. So now if we look at the config, and so of course you've got the MAC address sticky, and then of course we've got the one that it learnt for that particular port. But of course if we do show start, it will have the MAC address sticky, but it won't have that learnt one yet. So of course you can do copy run start now, and then if we look at it, it should have it in there. Now it's a permanent fixture. So of course, because I haven't configured anything else on port security, it's got a maximum of 1 MAC addresses. So if we do show port security, I think was the command, yes. You can see that it's got a max count of 1. It's got a current count of 1, which is all very happy. No violations because there's only 1 MAC address. If it does get a violation, of course, it will shut down. I haven't played around with any other settings, but so that's port security. Now we just got wireless. So now, of course, this isn't truly a Cisco device. So the internet address needs to be static. 10.99.02 255 255 255 10.99.01 is the gateway. And so we're going to set the IP LAN address to 10 199.0.1. Start at 150 addresses. That looks all right to me. Oh, shit. Seems to be quite random what it does with those. And so if I hit save, it should actually edited those to be correct now. Now, this has probably got the old address, yes. It's now got a new address. I got this working yesterday. Oh, at the moment, I don't care. All right, let's get the wireless settings. I must have picked the wrong router. Now, when it comes to that, we want an SSID of Flinders. So now, because I've changed the SSID, it's lost association. So from here, we're doing WPA2 personal, in other words, a pre-shared key, and it says to use password. All right, that's it for that. Now we've got to get the host with the same settings. Pre-shared key. And Flinders. We have connectivity. I don't know what's going on with this. I'm going to have to do some more research on these access points. 1099.02/24. I don't see any problems at all. So I haven't bothered with DNS, but that's about it.
So why is the internet address 9902?
Because this is its gateway. So 1099.0.1. Now it's connected via port 24. And that's why I didn't do the port security and stuff on that port, because it's an access point. I'm gonna have to find a better model of access point to use. I've never had troubles with the WRT 300s before, but yep.
Is that the
internet is the link to, yeah. So basically, there's an internet port on the switch, on the access point, and that's what's connected into port 24 there. Yeah, okay. There's no other ports that are actually active. They're all down. I think. Might just have a look, see if I can.
We add route to 10.191. No. If you add a static route to 10.199.0.
Well, it should actually just be the default port. Maybe I had it in the wrong cable. Let's have another try. Working now. Yeah, it is a different subnet. There we go. I had it in the wrong port. Okay, so that's the connection working. So let's try a little more adventurous. 10.4.0.10. Oops, I need to ping it, I suppose, don't I? So that's actually going out onto the over here. Working nicely. Wrong port. Bloody hell. All right. So that is pretty much all I was thinking of demoing for the day.